Good afternoon and welcome back to the STS-133 pre-flight briefings. Here this hour we're going to be talking about the 2 spacewalks planned for Discovery's mission, and to tell us about them we have the lead spacewalk officer for the mission, Art Thomason. We'll let Art start with opening remarks and then we'll take questions. Art?
Hello, my name is Art Thomason. Today I'll be walking through the 2 spacewalks that we have planned for STS-133. But before we roll the video for that, I'd like to introduce the EVA team. And can I get the graphics for the crew, please? Our lead spacewalker for the mission will be Tim Kopra. This will be Tim's second set of EVAs. He'll be wearing the suit with the red stripes, designating him as EV1 or the lead spacewalker. Alvin Drew will be our EV2. This will be Al's second flight. This will actually be his first time to venture out the door on a spacewalk. Al will be wearing the suit with the white stripes. Inside the shuttle, we'll have Nicole Stott. She'll be managing the spacewalk, and she'll be reading Tim and Al's procedures, walking them through the steps of their task. Nicole has previous EVA experience on STS-128. Also inside will be Mike Barrett. Mike will be helping the crew members get suited up and out the door before each EVA. Mike will also be operating the space station robotic arm in support of both EVA-1 and EVA-2. I'd also like to introduce the team that I'll be working with on the ground during the spacewalks. Got one of the best teams in the business. I'll have Ernie Bell, Devin Bolch, Joni Davidson, Jay Berger, and Scott Ray. And now for STS-133, we've had quite a few changes. This started out as a no EVA mission. About halfway through the training flow, we picked up 2 spacewalks, and then about 3/4 of the way through the training flow, we changed the content quite a bit due to the pump module failure on space station. As a result, the team has done an outstanding job of adapting to all the changes that have come their way. So I'd just like to thank the crew and the EVA team for all the hard work and long hours that they've put in to get us to the point where we are today. With that, I would like to roll the video for EVA-1. Both crew members will be starting out outside the U.S. joint airlock. They'll hand out the necessary bags that are required for the EVA. And then they'll get to work on the nadir side of the space station. They'll be working between the U.S. laboratory and Node 1. They'll be installing an extension cable. This will provide an extension to the power outlet J612. This extension is important because you won't be able to access this port as it is today once the permanent multi-purpose module is installed after this EVA. We'd also want access to this to provide contingency power to Node 3 in the event that it needs to be demated for a contingency EVA. From there, both crew members will head off and start preparing to return the failed pump module to external platform number 2. Tim will begin setting up the space station robotic arm. And off in the distance there on the mobile transporter, you can see the failed pump module that will be returned later in the EVA. Tim will be installing a portable foot restraint on the end of the robotic arm. He'll then ingress that foot restraint and head out to the failed pump module. Meanwhile, Al will be working on the port Ceta cart, while he'll be retrieving 2 bags that were left outside on the pump module EVAs. He will stow those on a portable foot restraint, and then carry that bundle down to external stowage platform 2. This is the permanent home for the pump module, external stowage platform 2, until it's returned on STS-135. Once Al gets back to external stowage platform 2, he'll stow the portable foot restraint and then begin routing the vent tool and vent tool extender that was contained in one of those bags. This will allow them to vent the 10 pounds of ammonia that's currently in the pump module at the beginning of EVA-2. Meanwhile, Tim will have translated up to the mobile transporter and will retrieve the failed pump module. He'll reorient it to get it in the correct orientation to be installed on external stowage platform 2. Here you can see Tim working the neutral buoyancy lab with the mock-up that we train with. The real pump module will weigh about 800 pounds. Tim and I will work together to get this partially installed, at which point they'll remove the adjustable grapple bar and temp stow that. The adjustable grapple bar was used to temporarily stow the pump module on the mobile transporter. They'll then drive 4 bolts to secure the pump module into place, mate the vent tool, and close the thermal blanket over the front face of the pump module. Tim and Al will then work together to stow the adjustable grapple bar on the flex hose rotary coupler. This is the permanent stowage location for this tool until it's needed on a later spacewalk. From there, the crew members will begin to tear down the arm. Tim will remove the portable foot restraint and stow it on external stowage platform 2 for use on EVA2 when Al begins venting of the pump module. And then Al will retrieve the portable foot restraint that he got from the CETA cart earlier. Now he'll be playing a bit of a shell game with foot restraints here once he arrives at Z1. He'll stow the foot restraint from the CETA cart. He'll then take some time to open 2 thermal blankets that are covering orbital replacement units. By opening the thermal blankets, it will provide Dexter access in case these orbital replacement units need to be changed out robotically by Dexter. He'll then remove a tool stanchion from the portable foot restraint that's going to need to come inside, move it over to the one he just brought up, and he'll retrieve the portable foot restraint that contains a heat shield on the bottom. This heat shield prevents this foot restraint from being installed in some of the worksite interfaces on the outside of Space Station. This is the last foot restraint that has this heat shield. So I will take it, put it back in the airlock, and between EVAs, they'll remove this heat shield, bring it back out at the beginning of EVA2. From there, both crew members will head out to the starboard truss near Express Logistics Carrier number 4 that was installed earlier in the mission. There they'll be installing a camera wedge. This wedge will cant the camera and camera stanchion inboard to allow access to the orbital replacement unit site that you see in the background there. Here you can see them removing the camera and stanchion in the neutral buoyancy lab. Once that's removed, Tim will hold the camera steady while Al installs a wedge in the installation location. They'll then reinstall the camera to the wedge, as you see them doing here, and now it'll be in its new configuration canted outboard with plenty of room to stow orbital replacement units on these FRAM sites. At this point, if everything's going well, we think we'll have time to perform a couple of get-aheads. The primary get-ahead that we would like to get accomplished on this flight is installing rail stubs. These stubs will extend the rails that the CETA cart and mobile transporter translate on, and will allow them to go to the starboardmost work site. This will allow robotics operations farther outboard on the starboard truss. Here you can see them installing the first section of stub on the nadir side. And there's also a Xena stub that they'll be installing. Now the nadir stub has a built-in stop on it. This stop will prevent the CETA cart and mobile transporter from traveling too far outboard off the end of the rails. Currently, there are in place 2 stops that can now be released. And this is also a get-ahead task that we hope to get done. There's the tether shuttle stop that prevents an EVA tool from going too far outboard. Here you can see Tim rotating out the tether shuttle stop. And then we also have the mobile transporter stop, or MT stop, that we also plan to stow. This prevents the CETA carts or mobile transporter from going too far outboard. With that, both crew members will translate back to the U.S. joint airlock and perform their final task. This is JAXA's message in a bottle. They'll use this to capture the vacuum of space and return it to Earth. Okay, I mentioned on EVA1 that they will be setting up a vent tool and vent tool extender. This will be used to vent the 10 pounds of ammonia that's currently inside the pump module. Now, the reason we have this tool is to protect the crew from the actual venting that takes place and from the ammonia. So you can see this end is going to attach to the pump module. And once it's attached to the pump module, we'll have another end. This is called the vent tool. And then we'll have this end will attach to the vent tool extender. You can see the 2 pieces mate here. They'll be locked into place. And then we have approximately 15 feet total of length. And this will be the nozzle that's at the end that the ammonia will be vented from. And so this nozzle, we have the option of clocking it in many different directions in 30-degree increments with an EVA changeout mechanism, or ECOM fitting, and that will connect to a handrail outside of the lab using a MUT end effector or multi-use tether end effector. You can see these jaws will then clamp around a handrail on the outside of Space Station. And so again, this is used to protect the crew and sensitive hardware on the space station from ammonia. And so with that, that leads us into our first task for EVA2. So let's roll the video. Both crew members will be starting out outside the US joint airlock once again. They'll retrieve the necessary bags for the spacewalk. And then Tim will grab the portable foot restraint that had the heat shield removed during the EVA, or between the EVAs. He'll stow that foot restraint outside, and now it'll be able to be installed in any of the worksite interfaces outside of Space Station. Al will head over to the pump module and get ready for the venting task. He'll ingress a portable foot restraint and open the thermal blanket on the front face. And then he'll throw the bail on the vent tool, and we expect all the ammonia to be vented out in approximately 10 seconds, but we're going to leave the valve open for 2 minutes just to make sure that we get all the residual ammonia out. At that point, Al will start cleaning up the vent tool and vent tool extender. He'll put them in their appropriate bags, and he'll return those bags to the zenith side of the airlock. The second bag that you see here contained the pump module jumper that was used during the increment pump module EVAs. Here you can see Al stowing those bags on the zenith side of the joint airlock. He'll then translate out starboard to Express Logistics Carrier number 4. And there he'll be removing a thermal blanket that was required for launch, but now that this ORU is receiving, or orbital replacement unit is receiving space station power, this blanket is no longer required. So he'll roll that up and stow it in a spacewalk bag. Meanwhile, Tim will be setting up the space station robotic arm on the Columbus module. There he'll be installing a portable foot restraint, and he'll get ready to remove the lightweight adapter plate assembly from Columbus. So here you can see Tim working in the neutral buoyancy lab. He'll have to rotate this lightweight adapter plate assembly 180 degrees in order to get it in the correct orientation to be stowed in the shuttle payload bay. This was part of a material science experiment. The other two components have been brought down. This is the third and final component that needs to be brought to the ground and contains about 10% of the data for the experiment. This experiment was originally launched on STS-123. Here you can see Tim riding the arm into the payload bay. He'll drive a single bolt to secure the lightweight adapter plate assembly to the side of the shuttle. He'll then ride the space station robotic arm over to Dexter, Canada's robot. Here you see a view out of the cupola that the robotics operator might see. Once he arrives at Dexter, he'll be installing a camera. This will be the final component to complete outfitting on Dexter. He'll then remove a thermal blanket on Dexter. This blanket was needed for launch, but now if Dexter's working hard on a given day, it may cause things to get too warm, so we'll remove this blanket. From there, he'll ride the robotic arm back to Columbus. See the arm translation path here coming past the orbiter. Once he's back at Columbus, he'll remove the portable foot restraint and reconfigure his tethers and be tethered back to space station. He'll then stow that portable foot restraint on the outside of Columbus, and then he'll head back to the robotic arm one more time, where he'll install a lens cover on one of the cameras on the elbow of the arm. Now this cover will protect the lens from the plumes of visiting vehicles when they arrive and depart. Meanwhile, Al will translate over to the port truss. Al has quite a translation path. He goes almost all the way starboard, then all the way port. Here on the port truss, he'll be installing a light. This light will illuminate the solar alpha rotary joint. and will provide lighting during night passes for the EV crew when they're working in this area. He'll then translate up to the zenith part of the truss. Once he gets there, he'll be reinstalling a thermal booty over a fluid quick disconnect. This is something that was noticed that was out of configuration, so he'll reinstall that to maintain the appropriate temperature for this fluid quick disconnect. He'll then translate down to the nadir side of the radiator, where he'll be troubleshooting 2 radiator grapple stow beams that were installed on STS-131. And when these were installed, they weren't as secure as we expected them to be, so I'll be going through some troubleshooting steps to get them resecured. These would be used in the event that we needed to change out a radiator. I will then head over to node 3. There he'll be removing a thermal blanket. This blanket has a couple of connectors underneath it that have created a tent, and because of this tent configuration, we're worried that it could get too hot. The connectors could get too warm, so by removing this blanket, we're mitigating that risk. From there, both crew members will head off to their final task. Tim will head over to Dexter, where he'll be installing a lens cover on Dexter, again to protect this camera and lens from the plume of visiting vehicles. And I will head to the mobile transporter, or the POA as we call it, the payload ORU accommodation, and he'll be installing a lens cover in this location as well. From there, both crew members will head back to the U.S. joint airlock, where they'll ingress and complete their final EVA. And that completes my briefing for today. I'd like to hand things back over to the moderator.
Okay, we'll take questions now, starting here at JSC first, and then moving on to Kennedy Space Center and NASA headquarters. Just a reminder to state your name and affiliation before your question.
Mark Carreau for Aviation Week. The power cord that gets installed early on the first EVA, I guess I was a little confused as to who's getting the emergency power. And then you mentioned something about in case of a contingency spacewalk, and it almost sounded like you were talking about if they had to remove one of the nodes or something for that. And I just wonder if you could connect those dots.
Sure. So J612 currently powers the airlock shell heaters. So what's going to happen is that they're going to remove the airlock shell heater power, then install an extension cable, and connect airlock shell heater back to that extension cable. So as far as power is concerned, it's going to be the same configuration. But now at this point, you have a cable that you're able to access in case you need to connect to it. So you have to break the connection with the airlock shell heater power and reconnect. Now, the reason we want this is when Node 3 was brought to space station, it actually had 2 launch to activation cables that provided temporary power for it. There is a case where we would have to change out a heat exchanger. And if that happened, we'd have to demate Node 3, and at which point it would have no power. So we would use this launch to activation cable to repower it during that time it was demated.
Hi, Robert Perlman with CollectSpace.com. With regards to message in the bottle, I realize it's an educational or symbolic activity. So how does it rank in terms of importance, in terms of NASA's agreement with JAXA to have it done? If you run into a length of time another task, does that just get pushed off the table? And following up on that, since it seems to be pretty rare that an educational or symbolic activities is scheduled during an EVA, can you think of any other examples from recent time that they've done something like this in space? Thanks.
I can't think of any other recent examples. It is a relatively high priority task, and that we plan to get it done on this mission. If we don't have time to get it done at the beginning of EVA 1, then we'll perform it first thing on EVA 2. And it is a very quick task, just probably about 10-15 minutes at most. They'll close the valve on it and take a photo. So it should be pretty quick.
I was confused, Bill Harwood, CBS. I was confused about the timing of the ammonia venting. Is that
Yes.
When does that happen?
That happens first thing on EVA 2.
EVA 2. And the tool. Where did you say that the jet would be pointed toward? I don't understand that.
It will be pointed nadir port on the U.S. lab.
Let me ask one more along those same lines, though. Where will the EV guys be when the stuff starts spewing?
Well, Tim, EV1, he's going to be on the lab and translating out to Columbus at that point, and then Al will be right near the pump module. So the pump module will be used to kind of shield him from the plume, but the plume will be pointed nadir, so it shouldn't be a concern.
Mark Kirkman with Interspace News. Just to follow up on that line of questioning, you said you expect it to take about 10 seconds. You may have also mentioned, what I'm trying to find out is how much ammonia do you think is in there?
It's about 10 pounds.
10 pounds?
Mm-hmm.
Okay. That was it.
Okay, I think that's all the questions here in the room for now. So we'll go next to NASA headquarters for questions there. Excuse me, Kennedy Space Center first.
Hello, this is Marcia Dunn of the Associated Press. You mentioned that the vent tool has a 15-foot give on it. Is it going to be unreal to its full length, or how will that work?
Yeah, it will be extended to pretty much its full length. It'll be routed along external stowage platform 2 and then over to the labbed handrail 237, I believe.
And how close, I'm sorry, I sort of missed part of the explanation for how all this is going to work. Al Drew is in charge at this point, so he will be 15 feet away operating the tool, but then you mentioned he's going to be behind the pump, so I'm visually not getting this.
Be at the pump module where one end is connected, and the other end will be about 15 feet away. And that will be connected to the lab. That's where the actual plume is going to be coming out. So the ammonia will travel down the tube out the nozzle.
And so you think there's very little opportunity for either sensitive equipment or a spacewalker to get sprayed? And just in case, are you going to use your usual clean-off plans if that happens?
That's correct. We're prepared for the ammonia decontamination if that's needed. And of course, that's anytime you're dealing with ammonia, that's always a possibility. Using the vent tool and vent tool extender, we are reducing the risk, but again, it's always a possibility.
Okay, I think that's the last of the questions at Kennedy Space Center. We'll go now to NASA headquarters.
Hi, this is Denise Chow from Space.com. My question is sort of related to Marcia's, but just wanted to know what the main risks are with the venting of the ammonia. Is it the plume? Is it leaks in the hose, or what are the main concerns there?
I think the main concern is the plume, and then also cleaning up the vent tool and vent tool extender after it's done if there's any residual ammonia. And so if the crew members do get ammonia on them, it's something that's happened before. We just want to make sure we don't bring that inside. So we have procedures to make sure that we don't do that. We'll have one crew member come over, do the inspection of the affected crew member. If they see any ammonia, they'll then use a warm metal tool to sublimate any ammonia off. At that point, we'll start a bake-out calculator. This will allow enough time for any residual ammonia to bake off the crew member, and so that'll depend on the locations they're at outside of space station as to how long this bake-out needs to happen. But they'll be able to perform their nominal EVA task during this time. And when they come back inside, they'll perform a test where they have a Draeger tube that will record the amount of ammonia in the airlock, and if it's not within acceptable limits, we'll have the crew come back outside and perform an additional bake-out. So all of this takes time. We'll make sure to protect enough time for the worst case to happen and get this additional bake-out done if needed.
Okay, I think that was the end of the questions at headquarters. Any other questions here in the room? Okay, I think that will wrap up our briefing then. Coming up next on NASA TV, we'll be showing some B-roll from the STS-133 pre-flight materials. And then coming up at 1 p.m. Central Time, we'll be back with a look at the station's first robotic crew member, Robonaut 2. That'll be followed at 2 p.m. by the STS-133 Crew News Conference. And of course, you can find out about all of these activities online at www.nasa.gov in the meantime. Thanks so much and have a great day.